Welcome to our channel Tech It Easy.
Today we will discuss about internal combustion stoves. Stove is basically a huge steel structure outside with refractory materials inside. Refractory bricks checkers absorbs heat during heating cycle and releases heat during cooling or on blast cycle. Functions of stoves. The primary function of stoves in internal combustion blast furnace stoves is to preheat air blast. Stoves preheat the air blast to a high temperature, around 1000 to 1200 degrees Celsius, before it enters the blast furnace, enhancing combustion efficiency and iron production. Recover waste heat. Stoves recover waste heat from the flue gases and transfer it to the air blast, reducing energy losses and improving overall efficiency. Improve combustion. Stoves ensure efficient combustion by providing a consistent and controlled supply of preheated air, fuel, and gas to the combustion chamber. Increase productivity. By preheating the air blast and recovering waste heat, stoves increase the productivity of the blast furnace, allowing for higher iron production rates. Reduce fuel consumption. Stoves help reduce fuel consumption by optimizing combustion efficiency and minimizing energy losses. Stove's structure. Main components are combustion chamber, ceramic burner, dome, partition wall, checker bricks, checker supporting grids columns, chimney, control isolation valves. Combustion chamber, the area where fuel and air mix and burn, producing heat. Fuel, BF gas, coke oven gas, is burned with combustion air to produce heat. The chamber is lined with high-temperature refractory materials, e.g. fire brick, castable refractory, to withstand extreme temperatures. Fuel, BF gas, coke oven gas, is injected into the chamber through ceramic burners or nozzles. Combustion air is supplied through separate channels or integrated with fuel injection. A pilot flame or ignition source ignites the fuel-air mixture. Dome encloses the combustion zone. The dome contains the fuel-air mixture and combustion process, maintaining a consistent temperature. Directs heat flow. The dome's shape helps direct heat from the combustion zone towards the regenerator. The dome is typically made from high-temperature refractory materials, like castable refractory, ceramic fiber etc. The dome's curved or arched shape promotes even heat distribution and helps contain the combustion process. The dome may be insulated to minimize heat loss and optimize heat transfer.
Ceramic burner. The ceramic burner injects fuel, BF gas, coke oven gas into the combustion chamber. The burner mixes fuel with combustion air, creating a homogeneous mixture for efficient combustion. The burner is made from high-temperature ceramic materials, silicon carbide, alumina, for durability and resistance to thermal shock. Multiple fuel injection ports ensures even fuel distribution and mixing with air. Air swirl vanes creates a swirling motion, enhancing air-fuel mixing and combustion efficiency. Improved combustion efficiency. The ceramic burner's design ensures efficient air-fuel mixing, leading to better combustion and reduced emissions. Increased durability. Ceramic materials withstand high temperatures and thermal stress, extending the burner's lifespan. Partition wall directs gas flow. The wall guides the flue gases and air blast through the regenerator, checker chamber, promoting even heat transfer and efficient combustion. The partition wall is made from high-temperature refractory materials, like fire brick, castable refractory, for durability and heat resistance. Regenerators, a heat exchanger that stores heat from the combustion gases during stove heating cycle and transfers it to the air blast during on-blast cycle. A series of refractory brickwork that allows the air blast to flow through and absorb heat from the regenerator. Checkers, a series of refractory brickwork or ceramic elements that allow gas flow and heat transfer. Flue gas channels, channels that direct the flue gases through the regenerator. Air blast channels, channels that direct the air blast through the regenerator. Insulation, the regenerator is often insulated to minimize heat loss. Alternating heating and cooling cycles, the regenerator operates in cycles, heating up during flue gas flow and cooling down during air blast flow. Heat transfer, the checkers absorb heat from the flue gases and transfer it to the air blast. The regenerator increases the air blast temperature, enhancing combustion efficiency and reducing fuel consumption. Reduced fuel consumption, by preheating the air blast, the regenerator reduces the energy required for combustion. The regenerator enables higher blast furnace temperatures, increasing iron production rates and lower fuel consumption. Checker supporting grids columns, the grids and columns support the checker brickwork or ceramic elements, maintaining their structure and alignment. The grids and columns help distribute the flue gases and air blast evenly through the regenerator.
Grids, typically made from heat-resistant materials, special cast steel, the grids provide a flat surface for the checker work. Columns, vertical supports that hold the grids and checker work in place, often made from special cast steel. Strategically placed openings in the grids and columns allow for gas flow and heat transfer. The grids and columns ensure even distribution of flue gases and air blast, promoting efficient heat transfer. Grids and columns maintain the stability of the checker work, preventing damage from thermal stress. Flues, channels that direct the combustion gases and air blast through the system. Chimney is a critical component of internal combustion blast furnace stoves, responsible for safely venting flue gases and maintaining a stable combustion process. The chimney vents flue gases from the combustion chamber and regenerator to the atmosphere. The chimney helps maintain a consistent draft, ensuring stable combustion and efficient heat transfer. The chimney is a vertical steel structure outside and inside, typically made from refractory materials like fire brick, ceramic. The chimney uses natural draft to vent flue gases, created by the temperature difference between the hot flue gases and the atmosphere. The chimney ensures safe venting of flue gases, reducing the risk of accidents and environmental pollution. The chimney helps maintain stable combustion conditions, improving efficiency and reducing fuel consumption. The chimney can be equipped with emission control systems, minimizing environmental impact. Valves control the flow of air, fuel, and combustion gases. Control valves regulate the flow of gases, air, and fuel to the combustion chamber and regenerator. Shut-off valves are used for start or stop of fuel gas, air, flue gas or cold blast, hot blast flow. Different stove operation, heating cycle, fuel injection, BFG, COG is injected into the combustion chamber. Combustion air supply, combustion air is supplied to the combustion chamber. Combustion, fuel and air mix, and combustion occurs. Heat generation, heat is generated and transferred to the regenerator. Regenerator heating, the regenerator stores heat from the flue gases. Flue gas venting, flue gases are vented to the atmosphere. Cooling cycle, fuel combustion air cutoff, fuel combustion air supply is cut off. Regenerator cooling, the regenerator cools down, releasing stored heat to the air blast. Air blast, the preheated air blast is directed to the blast furnace. Alternating cycles, heating cycle, also known as on gas, the stove operates in the heating cycle, generating heat and storing it in the regenerator and venting flue gases. Cooling cycle, also known as on blast, the stove switches to the cooling cycle, releasing stored heat to the air blast. Cycle repeat. The cycles repeat, alternating between heating and cooling to maximize efficiency. Valve sequence of operation. Stove isolate to on gas. Depressurizing valve, DPV open. Waste gas valve, WGV open. Depressurizing valve, DPV close. Combustion AIR shut-off valve CASOV open. Combustion AIR regulating valve CAV % open. Burner shut-off valve BSOV open. Gas safety shut-off valve GSSV open. Gas regulating valve GRV open. Gas bleeder valve close. Stove on gas to isolate. Gas regulating valve close. Burner shut-off valve close. Gas bleeder valve open. Gas safety shut-off valve close. Combustion AIR regulating valve close. Combustion AIR shut-off valve close. Waste gas valve close. Stove isolate to on blast. Pressurizing valve PV open. Hot blast valve HBV open. Cold blast valve CBV open. Pressurizing valve PV close. Stove on blast to isolate. Cold blast valve close. Hot blast valve close. Note: minimum one stove must be on blast mode to avoid interruption in continuous hot blast supply. On blast time 40 to 50 minutes. On gas time 70 to 90 minutes. WHRS Waste Heat Recovery System. A waste heat recovery system, WHRS, is designed to recover waste heat from stoves' flue gases and transfer it to the combustion AIR and BF gas, preheating. WHRS recovers waste heat from flue gases, reducing energy losses. Transfers recovered heat to the combustion AIR BF gas, preheating it before entering the stove for combustion. Efficiency improvement. WHRS improves overall efficiency, reducing fuel consumption and emissions. Types of WHRS. Recuperators use a heat exchanger to transfer heat from flue gases to the air blast. Regenerators store heat in a refractory material and transfer it to the air blast during alternating cycles. Heat exchangers use tubes or plates to transfer heat from flue gases to the air blast or other processes. Benefits: energy savings. WHRS reduces energy losses, minimizing fuel consumption. Emissions reduction. WHRS helps reduce emissions by minimizing fuel consumption. Increased productivity. WHRS improves blast furnace productivity by increasing the blast temperature. Components: heat exchangers, recuperators, regenerators, or heat exchangers. Ducting connects the WHRS to the stove. Control systems regulate WHRS operation, ensuring optimal performance. By implementing a WHRS, operators can significantly improve the efficiency and productivity of internal combustion stoves while minimizing energy losses and emissions.